So that way we can get to our mastery test, and I want to do that together. So that way, if you guys have questions, we can do it together.
Okay.
All right. So let's see. We just had Levi and Xavier join. Thanks, you two, for joining. Levi, you made it super fast. I thought you were going to be a little later. Good job.
I thought I was going to be a little bit later. But
It's okay.
then I actually ended up a little earlier.
Oh, got it. Okay. No big deal. I'm glad you're here. And then, so you did it already, Xavier? Thank you, sir. And Levi, just checked yours is done as well. All right, folks. So today, finally, we are going to see our last transformation rules. Remember, last week we were doing all the different rules for different transformations. So we first did reflection rules, and then we did rotation rules. Today we're going to look at these two, translations and dilations. So Tatiana asked about notes. Get your paper ready because we're going to need to have these down on some examples. I think these two are the, I don't know if I should say easier, but I think they're just more intuitive. They make a little more sense than the other rules do. So it's important to have all of last week's notes and today's notes together to do the mastery test. Okay? So we're going to be covering these three different topics: dilations, and then this is a special kind of dilation, a horizontal or vertical stretch. It's basically just doing it horizontally or just doing it vertically. And then we'll look at translations. That's where we're going today. Here we go. And as always, please feel free to interrupt if you have a question, or you can type it in the chat and I'll see it that way, okay? Okay, dilation. What is dilation? Now, we've done these before, but now we're going to look and see what a dilation is when we're looking at the points, the coordinates, just like our rules last week. So a dilation is an enlarging or shrinking of the original figure. And remember, we've done these before where we multiply the original by 3, or maybe multiply it by a half, and then it changes the original to a smaller or larger new version. So that's the basic idea of a dilation. We have a formula that we're going to use to be able to solve for how much bigger did it get. Here's our formula. Our old figure, think of this as the original, same idea, times the scale factor, that's how much bigger or smaller we're going to make it, equals the new figure. How much bigger or smaller? Usually scale factor is called K. I don't know why, but for some reason in all the math textbooks I've ever used, it's always called K. So here's a smaller version of our formula you can use. Old figure times K equals the new figure. So let's look at these two examples. We'll do the one on the left first. If we're starting with the little red triangle, we multiply it by K and it becomes bigger. This means we multiplied it by a number that's bigger than 1. So for example, maybe our original red triangle has side lengths of 4, 4, and 3. And if good morning, Victor. If I multiplied it by, maybe my K is 2, for example. So we know from our earlier work with dilations that this is going to multiply all the side lengths. They'll be 2 times bigger. So instead of 4, 4, and 3 for side lengths, my new blue resulting figure is 8, 8, and 6. So it's like taking the original, multiplying all the sides by K, and it gives you the new figure. And we can see the same thing happen, but going smaller. So if I start with my red triangle here, and let's say it's the same triangle, so 4, 4, and 3. But this time my K is a a fraction in between 0 and 1. So maybe we multiplied it by a half. So now it's going to take all those original sides and multiply them by a half. So 4 times a half. Can anyone tell me what we'll get when we multiply 4 times 1/2? Four times a half. Can anyone do that one for me? Or tell me how you start it, how you think about it. Okay, the silence tells me no one's ready to do this question. So, quick review. If I'm multiplying a fraction by a whole number, you're going to multiply the whole number to the top of the fraction. So we have 4 over 2. So can we divide or reduce that fraction of 4 over 2, 4 halves? Can anyone do that for me? 4 divided by 2?
Four divided by 2 is 2.
Levi showing up. So thank you, Levi. So that's going to happen to both of these sides. And then what happens with that side of 3? 3 times a half. That's our old times scale factor. Well, this comes to 3 over 2, which doesn't divide evenly, but we can divide it and you can get a decimal. Wait, there's something in the chat. Yes, Savannah, thank you for doing the last one too. 3 divided by 2 would give you 1.5. A decimal, but it's still half of 3. So this is what we've done before with dilations. Multiplying the old times the scale factor gives us the new. But today we're going to look at the exact points, the vertices of the triangle or of your shape. So for example, look at point A with me on the right figure. So we've been working with these figures on the actual coordinate plane. So if A is at a certain location, x, y, what happens to the new A when we multiply it by our scale factor of a half? That's what we're going to look at now. I'm going to move on. If you need me to stay on this screen, give me a heads up. Oh, I lost Anaya. Darn it. Hey, Anaya. I didn't realize you had dropped out of the call. I'm glad you're back. So I just did a brief review on what we've done before with dilations and scale factor. Now we're going to look at the actual coordinates or points of these figures. Okay, I took this from Edmentum as a practice question. A triangle with vertices at 0, 0, 0, 4, and 6, 0 is dilated to yield a triangle with these new vertices. A prime is 0, 0, B prime is 0, 10, and C prime is 15, 0. What is the scale factor of the dilation? So how can we find scale factor if we're only dealing with the points? The good news for us is that the formula for the side lengths works with the coordinates or the points as well. So for example, if I wanted to take the original ABC at 0, 0, B is at 0, 4, and C is at 6, 0, and we're going to multiply that by the scale factor that we don't know yet and get our newer one, which here's its points. It's A prime is still at 0, 0. B prime is higher at 0, 10. And then C prime is at 15, 0. The same thing that's happening to the side links themselves is happening to the coordinates. So if we compare an original point to its ending point and plug those into our formula for dilations, we can work backwards and solve it for what the scale factor is, or the dilation. I'm going to change my color quick. So remember the formula from the last screen is old times k for scale factor equals the new figure. So let's check out the B point, 0, 4, and the B prime at 0, 10. So notice 0, 4 to 0, 10, the x isn't changing here because it's a 0. 0 times the number is still 0. But the 4 changed to a 10. So we can plug those into our formula. Old was 4. Scale factor, we don't know. And new is 10. Excuse me. So now I've got 4 times k equals 10. If I solve this formula for k by dividing both sides by that 4, why do we divide by 4? Because it says 4 times k. We do opposites to solve our equations, opposites of the operations that are happening. So 4 over 4 cancels, and we have k equals 10 fourths. Or we can reduce that down by dividing the top and bottom by 2, and we get 5 halves. So the k, the scale factor, for this question is 5 halves. How did we solve it? We compared an old coordinate to the new coordinate. The same thing will work if we had chosen C instead. We can't choose A in this case because it looks like it is at the origin 0, 0, and it didn't move because those points are zeros already. But let's check it real quick for the C. Old C compared to the new C. Old C is at 6. New C is at 15. So 6 times k equals 15. Divide by 6. So k is 15 over 6. And if you reduce this by dividing 3 on top and 3 on the bottom, we get 5 halves. So we get the same k no matter which points you choose to use. The key here is using our formula, old figure times scale factor equals new figure. And you can pick any points that we have to compare old to new. I'm going to move on to a new one in just a moment. I'll wait 10 seconds if you're writing anything down still. Let me know if you need more time. Okay, let's look at a special case of these dilations now. Horizontal or vertical stretches. These are the same as a dilation, but it's only happening to the x for a horizontal stretch or only happening to the y for a vertical y. For a normal dilation, the times k is going to happen to the x and y. But if it says you're doing a horizontal or vertical stretch, you're only going to apply that to the x numbers or only apply it to the y numbers. So for example, let's just draw a little sketch of what this might look like. A horizontal stretch let's say we started with this rectangle, but then we do a horizontal stretch of times 3. So the original points are going to get a times 3 to just their x's. So let's say our points here were 0, 0, 0, 1, 5, 0, and 5, 1. So if I multiply times 3 to just the x numbers, we're going to still have 0, 0, because 0 times 3 is 0. And the one above that is going to be 0, 1 still. So it doesn't change those 2 points, but it does change the other 2 points to 15, 0, and 15, 1. So it's like a half dilation. We're only dealing with the horizontal x's or the vertical y's if it says it's a horizontal or vertical stretch. Let's try a example of this. Rectangle ABCD is stretched horizontally by a factor of 3. If the point C is located at 4, 2, what are the coordinates of the new C, C prime? So we don't know the locations of all the other points here, but it doesn't matter. We're only looking for the new C, and they told us the old C. Old times K is equal to new. So the old C point is at 4, 2. The factor, the scale factor is 3. And we're looking for new. Don't know it yet. Now, this is a horizontal stretch, so my times 3 is only going to apply to the x number. Remember, it's always x first, and then y. So 4 is the x number. So 3 times 4, 12, 2 is the new C, C prime. And that's that. So we have to pay attention. Are they asking us for a horizontal or a vertical? Or if they just say a dilation, then that's going to apply the times k to both x and y. Okay, I'm going to move on unless anyone would like more time. Let's look at translations now. So we talked about dilations and horizontal vertical stretches.
Do you think you could go back really quick?
Of course.
I was just finishing writing something down.
Sorry about that. Yeah, here we go.
That's all right. Okay.
Okay. Thanks, Levi, for letting me know. So translations. Now remember, translations means it's like sliding the figure across the graph. It's not going to rotate or get reflected or be dilated. It is just like taking the original one you start with and moving it up and over or down and over. Let's try an example on a picture here. Translate triangle ABCD or ABC up 5 units and right 8 units. So I'm going to draw in a triangle ABC. And I'm going to label its points. A is at -9, -4. B is at -7, -2, and then C is at -6, -4. Now, if I'm supposed to move this thing up 5 units and right 8 units, where does that put our new figure, our translated figure? I'm going to put this in purple. So every point we have, A, B, and C, needs to follow these directions. Go up 5 and right 8. So let's do this one point at a time. Looking at point A, up 5 would be up 1, 2, 3, 4, and 5. And then to the right 8, 1, 2, 3, 4, 5, 6, 7, 8. So here's new A prime. It's going up and over or down and over, and they'll tell us how much to do for each question or each problem. So now let's do that for B. So up 5, 1, 2, 3, 4, 5, and over 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it should have the same dimensions as the original ABC. On a picture like this, it's pretty intuitive and pretty easy, I think, to just count up and over following the directions they give you for the translation. But what if we don't have the picture and we're only dealing with the numbers? Let's see, the new A prime is at -1 up 1. The new B prime is at 1, 3. And the C prime is at 2, 1. So let's focus on just, let's look at B to B prime. Old B was at -7, -2, and the B prime is up at 1, 3. So if we examine the starting, the old, to the new for a translation, what's happening to X and happening to Y is going to be whatever the directions for the translation was. Here's what I mean. Old B, -7, that's for X. My directions for the translation were right 8 units. So X goes with horizontal, left and right. So if I go right 8, that's like adding 8. So -7 plus 8, -2 plus 5, because it said up 5. So if we simplify this, what do we get? We get -7 plus 8, that's 1. -2 plus 5, that's 3. And that's the new B point. So if we just apply the directions that they give you, up or down goes with Y, and left or right goes with X, then we can track those points even without making a picture. By adding 5 to Y and by adding 8 to X, we're able to see where the new point is compared to the old point. Let's try another example, but without the graph this time. Okay, translate triangle DEF down 3 units and right 10 units. DEF has the coordinates of -5, 0, -3, 6, and 2, 4. So our old triangle lives at these 3 points, has those 3 vertices. And they want us to say the new D prime, E prime, and F prime. So one at a time, we're going to apply the translation down 3. Down 3 means -3 for y. And right 10 means plus 10 for x. Remember, up, down goes with y, left, right goes with x. So let's try the D first. So for point D, it starts at -5, 0. But we need to go down 3, so that'll be -3 for y, and right 10 plus 10 for x. So now we've got to simplify each of those, and that'll tell us what D prime is. So -5 plus 10 is +5. 0 minus 3, -3. So now let's try it for E prime. Point E, the original is -3, 6. And we're going to do the same thing we did to the last one. We have to do -3 for y and apply a plus 10 for x. And then we're going to simplify the x portion and the y portion for E prime. So -3 plus 10, that's +7 left over, and 6 minus 3 is +3 left over. And there's E prime, 7, 3. Point F, the old F is at 2, 4. Apply down 3, so that's -3 for y, and plus 10 for x, because right 10. Oops, 4 minus 3 is just 1. And that's F prime. So we don't have rules necessarily to go with dilations and translations like we do for the reflections and rotations. But we need to know how to use the translation and apply left or right to x, up or down to y. And then for dilations, we're multiplying the scale factor to the original points. Old x and old y equals the new x and the new y for dilations. And then for translations, we're going to left means minus the change number, and right means plus. And then for y, a down means minus, or up means plus the change number. Okay, there's one more thing that you might get on your mastery test. So I want to show you that now. This goes with the translations. Using Pythagorean theorem to find the distance between translations. So if we're asked to do a translation to an old figure by going up and over or down and over a certain number of units, they might ask us, well, how many units did it actually move? What's the distance between the old one and the new one after we do like an up and over or down and over? And we can use Pythagorean theorem to find out how much that is. Let me change my color here. Triangle MNO is translated up 8 and 6 to the right to make triangle M prime, N prime, O prime. What is the distance between the two triangles? And we don't have any points given. They're just asking us how long is it? How far did it go from one to the next? So they're telling us it went up 8 and right 6. So up 8 and right 6. So we've just kind of made a right triangle by following those directions up and to the right. So this right triangle between my old and my new figures has a side of 8 and a side of 6. And if you remember, the Pythagorean theorem is side squared plus side squared equals hypotenuse squared. That's the longest side. So the two sides squareds, those are the two right sides that are making the 90-degree angle, the right angle. So if I plug in 8 squared plus 6 squared equals hypotenuse squared, we can solve backwards to find out the distance between the old and the new translations. 8 squared is 64. 6 squared, remember that means 6 times 6, that's 36. We add these and we get 100. So 100 is the hypotenuse squared. To figure out the actual hypotenuse and the distance here, we have to take the square root of 100 to cancel out that squaring. And that comes out to 10. So that means the distance between the old and the new is 10 units. There's one question in the mastery test that deals with finding the distance. So you might get this question or you might not, but the main focus is on doing the translations and doing the dilations or horizontal vertical stretches. That is it for today, but you're not released yet. I want all of you to start up your mastery test and do this one with me right now. It's called Representing Transformations in the Coordinate Plane. And while you're doing it, if you have any questions,
What is it called again?
we can do it together. Let's see, what is it called? I think it's called Representing Transformations in the Coordinate Plane. Oh, in a plane. Representing transformations in a plane. So it's the third one in Unit 7.
Okay.
And it's going to cover everything we did last week and these from today. So use your reflection and your rotation rules. Have those ready from your notes. And then it might also have dilations or translations. And if you want any help at all on the dilation stuff or the translations, just tell me which number you're on, or actually you'll need to read me the beginning of your question. Or you can share your screen and show me your question. Let's all knock this out today, even if you haven't done the other two or if you're behind or whatever. Let's just do this one together. Representing transformations in a plane.
I need help with the question.
Sure. Can you read me the beginning of it?
Okay. Can I just show you?
Yeah, go for it.
Here's.
Go for it.
I can't. Okay, there.
Okay, so you got the hard one. You got the distance one. So it's telling us triangle XYZ is translated 4 units up and 3 units to the left. So, and then they're saying, what is the distance between the old triangle and the new triangle? Well, we're going to do the same thing I just showed you guys with the Pythagorean theorem. So basically, you've got a triangle going up 4 and left 3. So you've got a right triangle with 4 on one side and 3 on the other. So I'm gonna stop you sharing. Come back to my screen real quick, would you?
Mhm.
Okay, so regardless of where X, Y, and Z live originally, it's going up 4 and then left 3. And even though it's going left, which we all know would be like -3, it doesn't really matter when we're making a triangle because this direction is 3 units leftwards. So even though it would be -3, we can't have a side length of -3. It has to be +3. So here's the right triangle we're dealing with for that question. So using the Pythagorean theorem, 4 squared plus 3 squared is equal to the distance squared, or the hypotenuse squared. So now 4 times 4 and then 3 times 3. Can you try those for me and tell me what you get?
Okay.
Okay. Remember, everybody, squared, this little 2 symbol, that means the number below the base multiplied by itself that many times. So that's why we're doing 4 times 4 and 3 times 3.
Okay, so what I got was 4 times 2.
Oh,
16.
Yes, 16. It's 4 times 4, right?
Mhm.
Good. And then 3 times 3?
9.
Yeah. So you've got 16 plus 9. What do those come to if you add 16 plus 9?
25.
25 is the hypotenuse squared. We take the square root, Tatiana. So square root of 25 is the distance. So now in your calculator, we got to find the square root button. Or you can ask yourself, what number times itself makes 25?
5.
Yeah, good. Very good. So 5 is the distance. It's the hypotenuse of this right triangle we made, or it's the distance between the two figures.
Okay.
Thank you for asking. Good job. Anyone else? If you have a question on your question, just don't hesitate. Let me know, and we'll do it together.
And then you guys will still have your free meeting time.
Hey Tatiana, I'm just gonna mute you for now, but unmute if you have another question.